So for task 3, we're going to define an arithmetic sequence and determine its function. So first we'll start with characteristics that we've noticed about arithmetic sequences. So the first being that the numbers form a pattern. The same number has to be added and subtracted every time to get the next number. And just as a side note, the number that is added or subtracted is called the common difference. Which we use the letter D. So a formal definition for this would be a list of numbers in which the difference between any two consecutive numbers is the same. So some examples would be, let's start with an easy one. 1, 2, 3, 4. So to get from 1 to 2, we have to add 1. 2 to 3, we add 1. 3 to 4, we add 1. So it looks like the common difference here is 1. Another example might be 7, 5, 3, 1. So the difference between 7 and 5 is -2. We're going down to -2. So the common difference here is -2. Right. And another example might be -16, -21, -26, -31. So here we have to go -5, -5, -5. So D would be negative. The common difference is -5. Another thing that's kind of interesting is that if you were to graph this, you would notice that, for instance, if we graphed the first one, 1, 2, 3, 4, so the first number is 1, the second number is 2, the third number is 3. Notice that you get a line. The same can be true for this graph. The first number is 7. 1, 2, 3, 4, 5, 6, 7. The second number is 5. The third number is 3. And then you can see this is also linear, which makes sense because the difference is constant. All right, so things that are not linear. 1, 4, 0, 3, for example. This is +3, this is -4, this is +3. It's not the same number. So even though it might be a pattern, maybe the next one is a -4, it doesn't have the same number, so wah wah. 1, 2, 4, 8, 16 is another example. From here to here it's +1, here it's +2, here it's +4, here it's +8. You can notice that these are not the same. So this is not an example of an arithmetic. And if you wanted to look at its graph, the first number is a 1, second number is 4, 3, 4, third number is 0. So you can see that this is not linear. So, a sequence may be referred to as A, or maybe you'll see something called this, like a sub n. The numbers in an ordered list are called terms. Okay, so for example, we see that this one, example 1, we have 2, 5, 11, 14, 17. A1 is the number 2 because it is the first term in our sequence. First term is 2. A2 is 5. That's our second term in the sequence. A3 is 11 because it is the third term in the sequence. But we want to know, what is AN? So we want to know what formula could we use to eventually find out what any number is. So first, to do this, we need to know, well, what is A0? So we know that here we have to go plus 3. Oops, this should be an 8 here. That means to find out what A0 is, we need to minus 3. So that would give us a negative 1. So our formula, since A0 is negative 1, AN is going to be the starting point, negative 1 plus 3n, because we're increasing our sequence by 3 every single time. Okay, here's another example. We have 5, 2, negative 1, negative 4, negative 7. So the first element in our list is 5. The second element in our sequence is 2, negative 1, so on and so forth. So we can see that we need to know what a to the 0 is. This is plus 3. No, I'm sorry, minus 3, minus 3, minus 3, minus 3. So if we need to go back a step to figure out what A0 is, that means we're actually going to be adding 3. So 5 and 3 makes 8. So to find out what any term is, we would start at 8, and then we would have to subtract 3 for every element. All right, take a moment, stop here, and see if you can do the rest. Great, if you take a look, these are the formulas for an arithmetic sequence. We always find the initial value, a to the 0, A0, a sub 0. And once we do that, we can add the slope, essentially, to every term in the next sequence.